In this videotape, we're going to look at some word problems whose solution gives rise to one first-degree equation. These are very simple word problems. I would also like to refer you to the appropriate tapes in the elementary algebra sequence. Okay, after you look at this one, you might want to see some other word problems, and we do have several word problem tapes in the other algebra sequence of videotapes. Okay, now, the first problem, and you have these on your problem sheets. If you do not have a problem sheet, you should ask the person who is running the lab for one. You should have the problems on a sheet before you start the tape. The first problem, and you should always read the problem at least twice, tells us that 8 times a number is 4 more than 6 times the number. Find the number. Okay, what we're going to do here is to assign a variable to the number that we're looking for here, and then try to translate this statement into mathematics, into a mathematical equation. We will then solve the resulting mathematical equation, and in this videotape, all the equations which result are first-degree equations. And after we solve the equation, we'll make sure that we have answered the problem, and then we will try to check the answer in the words of the problem. Okay, so let's see what we can do here. 8 times a number is 4 more than 6 times the number. Find the number. So let's let x equal the number that we're looking for. See what we have. 8 times the number, 8 times x, equals 4 more than 6 times the number. Well, 6 times the number would be 6x, and 4 more than that, we'd have 6x plus 4. Okay, now let's try it again. Let's see if it makes sense. 8 times a number is or equals 4 more than 6 times the number. So we have succeeded in translating this word problem into a mathematical equation, into a first-degree equation. Okay, this is a very simple equation to solve, of course. We would subtract 6x from both sides of the equation, giving us 8x minus 6x, or 2x, equals 6x minus 6x, that's 0, plus 4. 2x equals 4. We then divide both sides of the equation by 2, giving us x equals 2. We were looking for the number, and we believe that we have found it. We believe that the number that we're looking for is 2. But we have to check it. Now, to check this, we're going to go back to the statement of the problem. Okay? While most equations we simply check, okay? When we want to check just an algebraic equation, if this was the equation we were solving, we would simply go back to this, substitute it, and see if it works. With a word problem, it's better to go back to the actual statement of the problem, because it's possible that when you were translating this into mathematical equation, you made a mistake. Okay, so let's go back to the actual English in the word problem. 8 times a number. Well, the number, we claim that the answer is x equals 2. 8 times the number, 8 times 2, that would be 16. That should be 4 more than 6 times the number. Well, 6 times the number, that's 12. And it is true that 8 times the number is 4 more than 6 times the number. So it apparently does work out. We believe that the answer was 2, and we checked it out. 8 times 2, that's 16, should be 4 more than 6 times 2. And 16 is 4 more than 12. So it does work out. Okay, this was problem 1 on the problem sheet. We're now going to move over to problem number 2. It says the sum of 3 consecutive integers is 4 less than 4 times the smallest of the integers. Find the integers. Okay, now read that problem. Think about it for a few moments. Okay, now the problem is talking about 3 consecutive integers. Okay, when I'm talking about consecutive integers, I mean, say something like this, 3, 4, 5. These are consecutive integers. Notice that they go up by 1. So if, for example, I were to let x represent the first of the consecutive integers, the next one would be x plus 1, and the one after that, x plus 2. Consecutive integers. We're just trying to show you how one would indicate consecutive integers. Now, some problems have to do with consecutive even or odd integers. If we were talking about consecutive even integers or odd integers, it would work the same way. If, let's say, consecutive even integers, 2, 4, 6. That's what I mean by consecutive even integers. If x represents the smallest, then x plus 2 would be the next one in the sequence, and then x plus 4, the one after it. And odd integers would work the same way. For example, if you had 3, 5, and 7. If x represents the first, okay, you add 2 to get to the next, you add 2 to that to get to the last. If you had, say, 3 consecutive even or odd integers. Even or odd integers, of course, they differ by 2, whereas just consecutive integers, they differ by 1. So in all of these, we usually let the first one in the sequence be x. And then if they're just regular integers, consecutive integers, x, x plus 1, x plus 2, and so on can indicate them. If they are even integers or odd integers, we would go up by 2. Okay, keeping that in mind, we can go over here. We can say, let x equal the smallest of the integers, x equal the first or the smallest of the integers in this sequence, and then x plus 1 would be the second integer, and x plus 2 would be the third. These are consecutive integers, not even or odd, just consecutive integers. They're going up by 1. The sum of 3 consecutive integers. Okay, so we have indicated, okay, a representation for these integers. Now let's look at the problem. It says the sum of 3 consecutive integers, the sum means you'd add up this, this, and this, should be 4 less than 4 times the smallest. This is the smallest, the first in the sequence. Okay, so let's write that down. The sum of 3 consecutive integers, the first plus the second plus the third. You do not need the parentheses here. I'm just putting them there so that you should clarify it for you. The sum of the 3 consecutive integers is 4 less than 4 times the smallest of the integers. This is the smallest, x. 4 times the smallest is 4x, and we want 4 less than 4 times the smallest. See if this makes sense. The sum of the 3 consecutive integers is 4 less than 4 times the smallest of the integers. Okay, I'm just going to rewrite that equation up over here so that we can solve it. X plus x plus 1 plus x plus 2 equals 4x minus 4.
Tables on
X plus x plus 1 plus x plus 2 equals 4x minus 4. Okay, I just left out the parentheses, which we really did not need in the first place. Okay, let's collect like terms on the left side. X plus x plus x, that's 3x. 1 plus 2, that's plus 3, equals 4x minus 4. 3x plus 3 equals 4x minus 4. Okay, we can subtract 3x from both sides of this equation. 3 equals x minus 4. 3x goes out here, and here 4x minus 3x gives us 1x. We can then add 4 to both sides of this equation, giving us x equals 7. Okay, so let's see what the answer would be. Well, you just don't write x equals 7. You go back to the problem. You see what were they looking for here? Find the integers, all 3 of them. Okay, x is just the smallest, the first of the integers. So if x is 7, the second integer would be 7 plus 1, 8. The third would be 7 plus 2, 9. So we believe that the answer, that the integers are 7, 8, and 9. Those are the 3 consecutive integers. Now we have to check this in the words of the problem. Okay, we have found, remember, the answer is not just x equals 7, but 7, 8, and 9, the 3 consecutive integers. Okay, let's find the sum of the 3 consecutive integers. The sum would be 7 plus 8 plus 9. 15 plus 9, that's 24. According to the problem, the sum has to be 4 less than 4 times the smallest. Okay, 4 times the smallest. That's 4x. 4 times 7 is 28. And it is true that the sum, 24, is 4 less than 4 times the smallest. Okay, the sum of the 3 integers, consecutive integers, 7 plus 8 plus 9, 15 plus 9, that's 24. It should be 4 less than 4 times the smallest. Well, the smallest was 7. 4 times the smallest is 28. 4 less than 28 is 24, which is the sum, so it does check out. And we have done it correctly. For our third problem, we're going to do a perimeter problem. The length of a rectangle is 2 inches more than the width. The perimeter is 24 inches. Find the dimensions of the rectangle. The length of a rectangle is 2 inches more than the width. The perimeter is 24 inches. Find the dimensions of the rectangle. In a problem which involves a geometric shape, this one involves a rectangle, it's a good idea to make a sketch. It's a simple sketch in this case, but it's still helpful in working out the problem. We're talking about a rectangle. Okay, we have to assign variables to the unknowns. Let's let x equal the width of the rectangle. Strictly speaking, it's the number of inches in the width of the rectangle. This is in inches here. And since the length is 2 inches more than the width, we will let x plus 2 denote the length of the rectangle, also in inches. The length is 2 inches more than the width. Okay, in a rectangle, of course, the opposite sides have the same length. We have the width here and here, and the length here and here. The width, the length. We are told the perimeter is the distance around the rectangle. Okay? The perimeter is 24 inches. Well, the perimeter would be the length plus the width plus the length plus the width, the entire distance around, or 2 times the length plus 2 times the width. But you can just simply add it up as we go around. In other words, the perimeter of this rectangle is x plus 2 plus x plus x plus 2 plus x. That is to be 24 inches. X plus 2 plus x plus x plus 2 plus x. The perimeter is 24 inches. Find the dimensions of the rectangle. Okay, let's collect the like terms on the left side of this equation. We have x plus x plus x plus x, 4x, 2 plus 2 plus 4 equals 24. 4x plus 4 equals 24. Let me rewrite that here. 4x plus 4 equals 24. We will subtract 4 from both parts of the equation, giving us 4x equals 20. Divide both sides of the equation by 4, giving us x equals 5. For our answer, we are looking for the dimensions of the rectangle. We need, therefore, the width and the length. The width, of course, is x, and the length is x plus 2. The width is x. X is 5, so the width is 5 inches. The length, x plus 2, 5 plus 2, would be 7 inches. Now, we're to check this out. First of all, the length of the rectangle should be 2 inches more than the width. Of course, that does hold. Now, the perimeter of the rectangle, the distance around the rectangle, should be 24. So let's see what we have. We have 7 plus 5 plus 7 plus 5. 7 plus 5 plus 7 plus 5. The distance around the rectangle is, of course, 12 plus 12, 24. So it does check out. We have found the dimensions to be 5 inches and 7 inches. The length is 2 more than the width, and the perimeter is 24. The last problem on our sheet is the following. John is 3 years older than Bill. In 5 years, the sum of their ages will be 3 less than 3 times John's current age. What are their ages now? Okay, John is 3 years older than Bill. In 5 years, the sum of their ages will be 3 less than 3 times John's current age. What are their ages now? Now, when you first look at a problem like this, it looks horrible. But if you make yourself a little chart, it does help a lot. Bill, John. Now, and in 5 years. Okay, we have to start someplace. Since John is 3 years older than Bill, let's let X represent Bill's age now. Let X equal X equals Bill's age now, his current age. John is 3 years older than Bill, so John's age must be X plus 3. For example, if he were 10, he would be 10 plus 3, 13. He's 3 years older. In 5 years, he'll be 5 years older, so we add 5 to his age, be X plus 5. He'll be 5 years older. x plus 3 plus 5. He'll be x plus 8 years old. Okay, in 5 years, this is how old Bill will be. In 5 years, this is how old John will be. Okay, now we're ready to start. In 5 years, the sum of their ages, okay, that means x plus 5 plus x plus 8. The sum of their ages in 5 years will be 3 less than 3 times John's current age. John's current age is x plus 3. 3 times that. Here the parentheses are important because we're going to have to use the distributive law. This is 3 times John's current age. This is 3 less than that. And there we have our equation. In 5 years, the sum of their ages, x plus 5 plus x plus 8, will be 3 less than 3 times John's current age, which is x plus 3. Okay, let's see what we have. X plus x, that's 2x. 5 plus 8, that's 13, equals, be careful here, 3x plus 9. Distribute the 3 through the parentheses. 3 times x plus 3 times 3 minus 3. 2x plus 13 is 3x plus 6. Subtracting 2x from both sides of the equation, 13 equals x plus 6. Subtracting 6 from both sides of the equation, x equals 7. Okay, so what are their ages now? The answer would be now John and Bill. Let's do it, Bill and John. Okay. Now Bill's current age is x. That's 7. Bill is 7. John is 3 years older. X plus 3. 7 plus 3. John is 10. Now let's check this out. Let's see what we have here. Right now, Bill is 7. John is 10. In 5 years, he'll be 5 years older. 7 plus 5, he'll be 12. He'll be 5 years older. 7 plus 8, that's 15, or 5 more than 10. Of course, he'll still be 3 years older than Bill. That doesn't change. The question is, okay, John is 3 years older than Bill. That's all right. In 5 years, the sum of their ages, okay? In 5 years, the sum of their ages will be 27. That should be 3 less than 3 times John's current age. John's current age is 10. 3 times that is 30. 3 less than that is 27. So apparently it does work out. Let me write the formal check down here. In 5 years, the sum of their ages, which is 12 plus 15, that's 27. That's the sum of the ages in 5 years. That should be 3 less than 3 times John's current age. 3 times John's current age, that's 3 times 10, that's 30. And in 5 years, the sum of their ages should be 3 less than 3 times John's current age, and that does check out. And that brings us to the end of this tape.